Yes, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In this particular discussion, we're going to look at how to find the concept of finding an average referred to as the mode. And this, of course, is going to be a mode of grouped data. Now, in our last discussion, I basically mentioned that the concept of the mode refers to a value which occurs frequently in a particular distribution. And this is going to be, of course, concerning a particular set of data, perhaps in a discrete or a continuous frequency distribution. And in this case, if we have a discrete set of data, we're going to consider a particular value which is going to occur frequently in that set of values. Now, in case we have values perhaps of this specific range, we can consider a particular value which is going to occur frequently. And of course, in this case, we're going to see that the value of 5 is going to occur 2 times, contrary to other values of 3, 8, and 9. And therefore, we're going to have 5 as our mode in this specific value. Now, in some cases, we're going to have these particular values perhaps appearing in a set of perhaps 2 times. We can have this one given as such. And therefore, if we are going to consider these particular values, then therefore we're going to have an additional value which is going to occur 2 times. And in this case, we refer to this set of course, data as a bimodal data, in a sense that we are going to have 2 specific values which are going to occur in a frequent way, which is 5 and 9. Now, in this case, in some cases, we're going to have a specific set of data which is going to constitute of values which, of course, lack this aspect of data which are occurring in a frequent way. And this is going to be data that is going to constitute no value for the mode given as such. So we're going to look at particularly a set of grouped data, and this is going to be giving us a way of finding a general representation for finding the mode. Now, in our description of the construction of a frequency distribution table, stated that this is going to constitute a various range of data given in terms of classes, and these are going to be also given in terms of the number of times in which this specific class is going to appear in that specific set of data, and this is going to constitute the concept of a frequency. Now, we had mentioned a few characteristics which, of course, are going to be associated with this frequency distribution. And this is going to be a range of values from the lowest value of a class to the highest, referred to as the low class limit and the upper class limit given as such. And of course, in trying to find a mode for a group data, of course, that's going to be encompassing that specific set of particular values for the lower upper class limit and some of the characteristics we had looked at. So in that particular case, I mentioned that we're going to represent a mode using that particular notation, and for our group data, we are going to have mode represented as the sum of the lower class limit of the model class and then plus this specific class with it, and that's going to be multiplied with of course that specific value for delta 1. I'm going to elaborate on this basic representation for delta 1 and delta 2 and what basically they imply. So in this case, I've mentioned the concept of the lower class limit of the model class, and this is going to be given as such. So this is the lower class limit of the model class, and in this case, when I say about the model class, is the class which is having the highest frequency in this particular distribution, and therefore this is going to form our model class given as such, having the lower and the upper class limit given as such. So in this case, the value of W is going to represent the class size. And we decided from our previous discussion on the various definitions we are going to look at in the concept of statistics, that this basically constitutes the ratio of the range and the number of classes, which you are to find by finding the range for this specific set of data is going to be the highest value minus the lowest value, which is 75 minus 5, and the classes are going to be 1, 2, 3, 4, 5, 6, 7. So this basically is 70 divided by 7, which is going to give us 10. So the value for W basically is going to constitute a value of 10 given as such. So we can as well just give it in terms of 10. So we have said that the lower class limit of the model class is going to be a value over 45, which we have identified from this specific class, and the value of w is equivalent to 10. And then this specific other values that we're going to have for delta 1. Delta 1 basically represents the difference between frequency of the model class and the frequency of the class preceding the model class. So basically the frequency of the class preceding the model class is the class immediately behind the model class, and this of course is going to be the difference between the frequency of the model class, which is 31, minus the frequency of the class preceding the model class, 29, and this is going to give us a value for delta 1 basically, which is equivalent to 2. And then we're going to have this delta 2 being given as the difference between the frequency of the model class and the frequency of the class after the model class given as such, or following the model class given as such. And the frequency of the class following the model class is going to be giving us a value of 5. So this is going to imply the difference between that 1 and 5, which is basically 26. So the value for delta 2 basically is going to be our value for 26 given as such. And of course, as we have said, this particular description is going to give us the specific mode for that particular distribution. So therefore, if we do a direct substitution in this particular case, we can find our mode for that frequency distribution, whereby we have said that this is going to constitute the value of 45 plus the class width is a value of 10, and this is going to be multiplied by the value of delta 1, which is 2, divided by the sum of delta 1 and 2, which is 2 plus 26 given in that particular case. So this is going to give us a value of 45.71, which is going to be our mode evaluated from this set of group data. So that's how basically we're going to do a set of finding the mode for a group set of data as we proceed. And we're going to do other various examples which are going to assist us, of course, try to find several means of trying to evaluate the basic examples that we may come across. So kindly check our description boxes for various links of other similar videos. And I'd like to invite our member to kindly subscribe and also engage us in the comment section for more discussion. So that is it for now, guys. By God bless you. Catch us in our next video.